I want you to focus on this problem. It's very important, and it's the first time we're going to apply the work and energy principle on the dependent motion. All right. So as you can see, guys, for the dependent motion in chapter 2, find the relation of SV and A by knowing that the length of the rope is constant. In chapter 13, we can find the acceleration by applying the Newton's second law. Now here, guys, we can apply also the work and energy in order to find the speed or to find any other unknown. How? We're gonna see how. First of all, before reading the question, guys, I should put a datum. I should assume that this is SA. So this is the assumed direction of SA, and this is the assumed direction of SB. Guys, in fact, I know that SA and SB will not have, could not have their direction correct, which means, guys, I can have a negative SA and a positive SB but I am assuming their directions as downward, all right? Okay, so if I wanna, before reading the problem, if I wanna find the relation SA and SB, I know that 2SA plus SB is equal to constant, and this, guys, will give me that 2VA plus VB is equal to 0, and I know that 2AA plus AB is equal to 0. Right, guys? You can do it. You can start by doing the constant length of the rope, and then you can find these equations. However, guys, in such a problem, I don't need S. I rather need delta S, because I want to apply the equation of work and energy, or the principle of work and energy. So in such a problem, I don't need S. I need delta S. Now, how can I find the relation between delta SA and delta SB? In fact, guys, this equation here is always correct. So it's always correct. Now, if I want to do this equation at zero, at state 0, I'm going to have also 2SA0 plus SB0 is equal to constant, and this is the same constant, all right? So it's always the same constant at any time, at any position. If I do the subtraction between these two equations, what I'm going to have, it will be 2 delta SA plus delta SB is equal to what? Is equal to 0. Perfect, Noor. All right? Which means, guys, if I have a dependent motion and I need to apply the work and energy principle, I can directly state that the displacement equation or the displacement relation is equal to 0. All right? So you can directly say, guys, that because here I have two rows. 2 delta SA plus delta SB is equal to 0. So I'm going to use this equation in this problem. All right? So to apply the work and energy principle, I'm going to use this equation. Now, guys, what is the direction of delta SA? What assumed direction of delta SA and delta SB? You have to know, guys, that since I am, guys, writing the relation between delta SA and delta SB, this means, guys, that I am also taking the same positive direction. So I'm assuming that this is the positive direction for delta SA, and this is the positive direction for delta SB, which means also, guys, I'm going to have one negative and one positive. Which one do you think it will be negative, guys? Which one? Delta SA. Perfect, Jad. Why? Because in fact, guys, A is lighter than B, and there is 2 parts of rope holding A, while there is only 1 part of rope holding B, although B is heavier. And this means, guys, that B, since it is heavier and 1 part of rope is holding B, B will be going downward. So B will be going downward, which means delta SB, SB, VB, AB will be positive. Why? A will be going upward. The motion of A will be upward because in fact A is lighter. So A will be going upward. Delta SA, SA, VA will be negative. All right, guys? Now, if you go back to the question, so guys, so far we did not read the question, all right? So I'm gonna read the question now. I have a cylinder A that has a mass of 3 kilograms and a cylinder B that has a mass of 8 kilograms. In fact, we use these two masses in order to know what is the direction of motion. I need to determine the speed of A. So delta SA is 2 meters starting from rest. So what does this mean, guys? They are giving me delta SA. Do you think that delta SA will be +2 or -2? Delta SA will be -2. Perfect, because I know, guys, in fact, I know that delta SA should be negative because A is going upward. However, I'm going to apply the principle of work and energy, assuming these two as my positive direction. So I'm going to assume these two as my positive direction. I'm going to apply the work of energy and principle, assuming that these two are my positive direction. And then whenever I want to substitute, I can substitute delta SA by its algebraic form, which is -2. All right? So let's do it. Let's apply the principle of work and energy. I know, guys, for A, that T0A, so why am I starting from 0? Because they are saying that it is starting from it. From the sum of work from 0 to 1 on A is equal to T1A, all right? And this is what I need to find. I need to find T1A because, in fact, I need to find VA. Now, what are the work done on this A? I have the weight, and I have, in fact, 2 tensions, all right? So if I'm assuming that this is my positive direction, so the positive direction of delta SA is downward, the weight is downward, then the work will be assumed positive. So the work of the weight will be MAG delta SA. Why? Because this weight and this delta have the same positive direction. But I know, guys, that inside delta SA, they're gonna be a negative sign. Now, plus, what about the tension here, guys? The tension is upward. Delta SA is assumed positive downward, which means I'm gonna have a negative sign for the tension. So -2T delta SA. And why, guys, I'm not putting any cosine? Because as you can see, the angle between these forces and delta SA is 0. They are collinear. And this will be equal to half MA VA squared. For B, so for B, I also have MBG delta SB minus T delta SB is equal to half MB VB squared. So how many unknowns? I don't know delta SB, I don't know VA, I don't know VB, but I know, guys, that delta SA, 2 delta SA, sorry, plus delta SB is equal to 0, and I know that 2 VA plus VB is equal to 0, and I know also, guys, that delta SA is equal to what? It's equal to -2. All right? So now, guys, if you replace delta SA in the first equation, what you're going to have, guys? You're going to have -2 MAG, which means that now the work is negative because, in fact, it should be. Since I know that it's going upward and the weight is downward, then the work of the weight will be negative. And then if you replace delta SA here by -2, the work of the tension will be positive, and this is what I should have. So times 2, so it's 40. And this will be equal to half MAVA squared. And delta SB will be equal to positive 4. So delta SB will be equal to positive 4. Now, if you replace this delta SB here, what you're going to have is a positive work of the weight, which is expected because because B is moving downward with the weight. So 4 mBg minus the tension of B is upward while B is moving downward, so the work will be negative. And the last equation that I have to use is the equation of VA and VB. So I'm going to have 3 unknowns, VA, VB, and tension with the 3 equations. Before you ask me any question, there is another strategy to solve such a problem. So it is by starting from here, by saying that since delta SA is negative and it's equal to -2, then the work of the weight should be negative and the work of the tension for A should be positive since A is moving upward. So A is moving upward, then the work of the weight should be negative and the work of the tension should be positive. And in this case, guys, what you can do is to use the absolute value of delta SA by putting the sign of the work of the weight. So I can say it should be negative. The work of the weight should be negative, which means MAG, absolute value of delta SA. Here, guys, I have to put an absolute value of delta SA because if I don't put this absolute value, minus will be plus, which is not correct because I know that the work of the weight should be negative. And I know that the work of tension should be positive, and in this case, I'm going to also put an absolute value for A is equal to half MAVA squared. Now for B, it is the same because absolute value, because B is moving downward with the delta S. So you can use, guys, the absolute value if you know, because you know, in fact, the sign of the work of the weight and the sign of the work of the tension, all right? Or you can do like I did here, so I kept this delta SA in its algebraic form. The second question that the first section asked me, guys, they asked me why I did not use the work of the weight as minus mg delta y. I used plus mg delta s. In fact, guys, this equation is in terms of delta y, and you have to know, guys, that delta y is always upward. It's in the same direction of y. While here delta SA is downward, then delta S is always equal to minus delta y. So if you replace this delta S with delta y, then the work of the weight, and this will be the third equation of the work of the weight in dependent motion, is mg delta S. So it's positive mg delta S when delta S is assumed downward. And don't forget, guys, that this delta S is algebraic. So it could be negative or positive. But since it is assumed downward, then I should say that the work of the weight is plus mg algebraic value of delta S and not absolute value of delta S. So as a recap, if I have a dependent motion and I need to do the work and energy principle, first of all, I have to predict what is the sign of delta SA and delta SB from the mass, all right, from the mass and from the configuration. Since here A is lighter than B and 2 parts of the slope is holding A, while one part of the slope is holding the heavier mass, which is B, then of course A will go upward and B will go downward. It's heavier, guys. All right? So I know that my assumed delta SA will be negative, while assumed delta SB will be positive. So you can solve this problem either by taking the algebraic value of delta SA, and then in this case, you're going to assume, since delta SA is downward, you're going to assume that the work is plus MAG delta SA for A and plus MBG delta SB for B, while both of the work of tensions for A and B will be negative by using delta S as algebraic form. Or Since you know, guys, the motion of A and B, you can use the absolute value for delta as A and the absolute value for delta as B. But in this case, you're gonna know what is the sign of the work. So it's gonna be negative for the weight of A, positive for the weight of B, positive for the tension of A, and negative for the tension of B, because you know the motion. All right?